The maiden flight of the B-21 Raider has unveiled the entirety of this cutting-edge 6th-generation bomber, showcasing a secret weapon technology that will change everything, including the rear, that were previously hidden in secrecy. How does the B-21 Raider fit into the larger family of systems for U.S. air power, and what is its envisioned role in future military operations? Join us as we investigate the revelations from the Raider's first flight and understand the reasons why this will change the way we perceive military air forces. It's a testament to America's enduring advantages in ingenuity and innovation, and it's proof of the department's long-term commitment to building advanced capabilities that will fortify America's ability to deter aggression today and into the future. Secretary of Defense Lloyd J. Austin III. In the pre-dawn silence enveloping the vastness of the western Mojave Desert, workers move through a dimly lit parking lot, heading toward an extensive complex of factories, hangars, and runways. Armed military and civilian guards patrol the grounds, vigilant in the darkness surrounding the 5,800-acre facility. This highly secure compound is fortified by an intricate security system, overseen from space by orbiting reconnaissance satellites. Approaching a perimeter fence lined with razor wire, personnel retrieve key cards from their belt loop lanyards. Swiftly, they flash these cards on a contact sensor, input numerical codes, and navigate through imposing turnstiles. Inside, signal-emitting electronics are stowed on storage shelves, and individuals verify their identities and security clearance at computer monitors. Finally, they step onto a pristine production floor that spans several football fields, a domain accessible only to those authorized to enter the covert world of U.S. government secrecy, known as SAR. Special access required. Welcome to U.S. Air Force Plant 42, the birthplace of the military's cutting-edge stealth bomber, the B-21 Raider. Emerging from nearly a decade in obscurity, the B-21 was unveiled on the evening of December the 2nd to an exclusive assembly of 3,000 attendees. Among them were Defense Secretary Lloyd Austin, top military generals, industry executives, and factory workers. As the hangar doors parted and artificial fog billowed, the sleek gray aircraft, resembling a Stingray, glided into view. Positioned 75 feet away, the audience, allowed only a head-on view, erupted in applause, maintaining the veil of secrecy surrounding the project. Later, Secretary Austin highlighted the B-21's capabilities, emphasizing its capacity to carry both nuclear and conventional munitions, as well as future weapons yet to be developed. He conveyed a clear message to potential adversaries, stating, "We make it clear to every possible enemy, the risks and costs of aggression far outweigh any conceivable gains." In the evolving Cold War scenario with Russia and China, the B-21 stands as America's inaugural advanced weapons system. The U.S. Air Force unveiled 2 new images of the B-21 Raider in March. This stealth bomber, developed in collaboration with Northrop Grumman, is poised to play a central role in the future of U.S. air power, leading a suite of systems integrating advanced data, sensors, and weapons. With 6th-generation capabilities encompassing stealth, information advantage, and open architecture, the B-21 is designed for network-centric operations across multiple systems and domains. Supported by a digital ecosystem throughout its lifecycle, the B-21 Raider can rapidly evolve through technology upgrades, staying ahead of emerging threats. Secretary of the Air Force Frank Kendall, speaking at the Air Force Association Warfare Symposium, emphasized the B-21's significance as the cornerstone of the global strike family of systems. While operational deployment is still a few years away, the B-21 Raider was officially unveiled in December 2022, marking the introduction of the first new strategic bomber since the end of the Cold War. The B-21 is designed to replace aging B-1 and B-2 bombers, offering enhanced capability and adaptability. The aircraft, featuring a sleek design and advanced technology, represents a pivotal leap forward in fortifying U.S. national security objectives and assuring global allies and partners. Pentagon strategists envision the radar-evading B-21 penetrating the air defenses of Russia and China, striking fortified targets in the event of escalating military tensions. If the meticulously laid-out plan proceeds, aerospace giant Northrop Grumman Corps will manufacture a minimum of 100 B-21s for the Air Force in the coming years. each commanding a current cost of $692 million, a financial commitment comparable to that of erecting a skyscraper. But the journey from well-funded Pentagon plans to actually having advanced weapons in use is filled with costly mistakes. For almost 40 years, the Air Force has struggled to buy new planes on time, within budget, and in sufficient quantities. The last time they bought a bomber, in the 1980s, they wanted 132 planes at around $500 million each. Instead, they got 21 bombers at a staggering $2 billion per aircraft. Northrop, their partner on that project, faced production delays and engineering challenges. The predecessor of the B-21, the B-2, produced at the same facility, became a symbol of a broken procurement process, a high-tech weapon that's expensive, scarce, and rarely used. Now the question is whether Northrop and the Air Force have learned from past mistakes before venturing into this new massive strategic endeavor. Time has been monitoring the development of the B-21 for a year, visiting Plant 42 before the rollout, observing the teams, speaking with military, industry, and political personnel, and reviewing documents detailing costs and development. While the program has achieved early milestones, the biggest challenges still lie ahead, especially in managing the risks, technical complexities, and costs associated with major programs like the B-21. It's not just money on the line. The success or failure of the B-21 program may decide whether the U.S. keeps an advantage in long-range bombers over global rivals, or burdens taxpayers with interest payments for another expensive budget project for years to come. Each B-21 starts as a wedge-shaped shell in Building 401 at Plant 42, progressing down the line through workstations, transforming into a bomber with avionics, radars, sensors, weapons bays, windows, and wings. Unlike traditional planes built from the inside out, stealth crafts like the B-21 are constructed from the outside in. The goal is to keep the jet's exterior as smooth as possible, like glass, to minimize radar reflections. Stealth is the B-21's key feature. Northrop's engineers have worked to create a plane that can fly undetected through enemy airspace, remaining invisible to missiles and fighter jets. The B-21 is designed to fly at subsonic speeds, powered by jet engines embedded into the wings. High-tech coatings are applied to the exterior, creating a sponge-like skin known for absorbing radar waves. The goal is for the B-21 to be even stealthier than the B-2, which reportedly appeared no larger than a tennis ball on radar screens despite its wingspan comparable to a 747 jumbo jet. The aerospace industry was surprised when the underdog Northrop secured the B-21 contract in 2015, beating out a joint bid from Boeing Co. and Lockheed Martin Corp., the nation's two largest defense contractors. Northrop's success with the B-2 transformed it from a small firm known for lightweight fighters into a major defense player. However, the B-2, despite its revolutionary radar-evading capabilities, earned a reputation as a hangar queen due to its demanding maintenance needs and sensitivity to weather conditions. For every hour in the air, the B-2 spends 51 hours on the ground for maintenance, costing $150,741 per airborne hour, according to the Government Accountability Office. Northrop claims that stealth technology has advanced significantly since the B-2 era, and the lessons learned from the B-2's challenges are applied to the B-21. The final delivery of the B-2 Spirit, the last operational stealthy long-range strategic bomber, occurred in 2000, marking a significant era for the U.S. Air Force, as it possessed the sole operational stealthy strategic bomber capable of nuclear weapon delivery. Subsequently, in 2014, the U.S. Air Force initiated the Long Range Strike Bomber (LRSB) project to secure a successor for the B-2. Renowned aerospace companies such as Boeing, Lockheed Martin, and Northrop Grumman engaged in the development of the new bomber. In 2015, the design proposed by Northrop Grumman gained the U.S. Air Force's nod, building on the company's previous experience producing the B-2 Spirit bomber. The development and assembly of the inaugural bomber commenced in 2016, receiving the official designation B-21 that same year. While the B-21 Raider shares a semblance of design with the B-2 Spirit, it is an entirely new aircraft rather than a modified version of its predecessor. By 2021, reports surfaced indicating the completion of two B-21 bombers, poised for testing. The public unveiling of the B-21 occurred in 2022, and its maiden flight took place in 2023. Anticipated to achieve initial operating capability in the coming years, the B-21 Raider is set to become a cornerstone in the U.S. long-range bomber fleet, standing alongside the older B-2 Spirit, B-1B Lancer, and B-52 Stratofortress strategic bombers. Unlike the B-2, the B-21 is designed to be left outside under a shelter like other planes, and its maintenance doors are meant to open more easily. While the B-2 requires specialized hangars, the B-21 is designed to fly daily without requiring extensive maintenance periods. The B-21 is intended to fly thousands of miles, evade enemy air defenses, drop bombs, and support U.S. and allied forces. The B-21 project enjoys bipartisan support, partly fueled by lobbying efforts, with Northrop spending $8.7 million on lobbying in 2022. The program is highlighted as providing 8,000 jobs across 40 states, with the potential for more as production expands. Exploring the prototype B-21 Raider, serial number 001, reveals an unexpected feature. The aircraft has a name. Last Friday's flight showcased the B-21 Raider, now named Cerberus, through excellent photography at Point Mugu skies. This naming choice, drawing from Greek mythology where Cerberus is the Hound of Hades, seems fitting for an aircraft destined to be one of the most destructive ever. As we delve into the aircraft, the rear aspect, hidden until this flight, aligns perfectly with the high-altitude flight profile we anticipated. Unlike the B-2 Spirit, which underwent extensive redesigns for low-level flying, the B-21 Raider seems designed without this requirement, a positive aspect of its configuration. Witnessing the bomber's first flight, keen observers noticed a long trailing wire, an aerial towed by the B-21. While sparking speculation, these wires are common for initial test flights, capturing undisturbed air or static measurements. Further enhancing our journey through Cerberus 1, we discover a long flight test air data probe at the front, measuring ram air moving into the aircraft akin to a pitot tube on conventional airplanes. The B-21 Raider, evolving from the B-2 Spirit, showcases significant improvements in engine air inlets. Unlike the B-2, the B-21's inlets, protruding from the top, minimize the risk of detection by enemy radars, enhancing its stealth capabilities. Taking a closer look at what the B-21 designers have accomplished, they've ingeniously crafted the engine inlets to be as low profile and conformal to the flying wing as possible. Unlike conventional aircraft with fuselages, the flying wing design integrates all components, including the cockpit, into a single wing structure. The decision to lower the air intakes is strategic, aiming to reduce the radar cross-section RCS for enhanced stealth and avoidance of detection. However, this adjustment introduces challenges, notably with boundary layer air. Many modern aircraft, especially stealth ones, use S-shaped or serpentine ducts to conceal engine fan blades from radar. These blades, perpendicular to airflow, act like mirrors for detection radars. To address this, aircraft designers create convoluted air tunnels to feed the engine with vital air while keeping the blades hidden. Lowering the intakes on the B-21 raises challenges, particularly in maintaining sufficient airflow into the engine. This becomes even more complex during supersonic flight or high-pitch flight regimes like takeoff, climb, and landing. The B-21 Raider appears to overcome this by employing large triangular doors, akin to butterfly inlets, which open up during high alpha or other flight regimes to ensure an adequate air supply to the engines. The importance of keeping the height of these inlets as low as possible cannot be overstated. It is a critical factor in determining the radar's stealthiness. The unique appearance of the radar horns, or devilish features of the B-21 Raider's inlets, might explain the choice of naming it Cerberus. The engines, as of the making of this video, the type and number of engines remain unknown. However, given its size, it's likely the B-21 has 2 engines, even though initial speculation suggested 4 engines. Exploring new aspects of the bomber, the video reveals the belly of the B-21 Raider, showcasing the apparent single weapons bay. Compared to the larger B-2, the B-21's weapon bay is smaller, proposing a reduced capacity. The question arises regarding the weapons the B-21 will carry, and one notable candidate is the GBU-57B Massive Ordnance Penetrator MOP, the world's most powerful conventional bunker buster. The B-21, with its open architecture systems, is designed to accommodate new weapons, configurations, and even air-launched drones. However, details about potential secondary weapons bays, similar to those in the F-35 Lightning and F-22 Raptor, remain undisclosed. The unveiling of these features adds to the intrigue surrounding the capabilities of the B-21 Raider. In both these aircraft, the secondary bays house heat-seeking AIM-9 sidewinders. Envisioning the B-21 Raider, we can anticipate the use of secondary weapons bays for self-protection air-to-air missiles like sidewinders or even AIM-120 AMRAAMs. Given that the Raider is an all-new aircraft, it might also employ the AGM-260 Joint Air-to-Surface Standoff Missile. As we haven't seen the Raider with open bay doors yet, these secondary bays could be located right next to the main weapons bay. Until more information becomes available, the specific arrangement remains uncertain. What we do know is that the B-21 maintains a lighter color compared to the B-2 Spirit. The Raider's light gray coating suggests its capability to operate in both day and night conditions. Another noteworthy feature is the relatively smaller size of the B-21 when viewed from the side, a common characteristic of flying wings. Although wide for lift production, flying wings are not as long as conventional aircraft, evident in a comparison with a B-52. This shorter length likely contributes to reducing the radar cross-section from various angles. The B-21 Raider is currently undergoing flight testing, states Air Force spokesperson Ann Stefanik to Aerospace Daily. This critical phase is part of the test campaign managed by the Air Force Test Center and 412th Test Wing's B-21 Combined Test Force. Its purpose is to provide survivable, long-range, penetrating strike capabilities, deterring aggression and strategic attacks against the U.S., allies, and partners. The commencement of flight testing follows the recent observation of the B-21 conducting daylight taxi tests in Palmdale, occurring less than a month ago. The initial aircraft is now set to undergo developmental testing at Edwards AFB, California. The revealed video showcases the flying wing aircraft with a straightforward W-shaped trailing edge, exhibiting a sleek design with an almost unblemished underside. The deeper center body, in contrast to the B-2, is noticeable, and the undersurface between the main and nose gear appears essentially flat. The cambered leading edges and trailing edge control surfaces, including the outer split surface drag rudders, are also evident. The Air Force, in a statement, notes that the program is currently in the engineering and manufacturing development phase, with plans to deliver aircraft to Ellsworth, AFB, South Dakota in the mid-2020s. 6 aircraft are currently in production, with the test aircraft sharing the same production line and tooling as upcoming production models. Despite maintaining secrecy about specific test milestones, the flight test is a crucial step. A successful first flight is required for the Air Force to proceed with awarding Northrop Grumman its first low-rate production contract. Northrop Grumman emphasizes that the robust flight test campaign involves a combined test force comprising both Northrop Grumman and Air Force personnel. This collaborative effort aims to validate digital models and brings the program closer to achieving operational capability, as stated by the company in a release statement. Much has transpired since last year's reveal, and the anticipation for more details is shared by many. Do you consider the Raider the most advanced aircraft currently flying? What are your thoughts on its RCS? Share your opinions in the comments below.